Hello, my name is Muhammad Imran bin Muhammad Iskandar. Welcome to a video presentation about Assignment 2 of Environmental Health Analytical Instrumentation, or LEV20202T. This is a subject taught by Dr. Azalina Susianti binti Faisal and is within a program called Bachelor in Environmental Health, or BEV. It is within a faculty known as the Faculty of Health and Life Sciences (FHLS) from Management and Science University campus, or what we would sometimes refer to as MSU Shah Alam. For this video assignment, I am covering a topic regarding environmental instruments. As you can guess from their name and reference, the main purpose for their existence is to either measure, monitor, observe, and collect data from various aspects in our environment. These environmental factors include humidity, temperature, pH levels, solution concentrations, wind speed, rate of decay, chemical compositions, noise frequency, liquid volumes, light intensity, radiation levels, noise measurement, voltage, electrical resistance, pressure, time, etc. They are very useful for updating knowledge on natural phenomena, giving foresight into making plans which improve the happiness and safety of people, generating profit in industries, and facilitating their conservation and protection of Earth's natural environments. It should be noted that environmental instruments appear in all sorts of sizes, varying in terms of machine complexity, and that each instrument often is only designed to measure one specific aspect of the environment. For this project of mine, I will be describing two general types of instruments that measure two different aspects of air quality. The presentation will describe the components which make up different versions of each instrument first. Then it will explain the functions of both types of instruments. After that, it will go over the step-by-step procedures on how to use each equipment. Next, it will state the advantages and disadvantages of both instruments' variations. Finally, the video will close off with a summary on the main findings of the video presentation. The first general instrument in question that I will introduce is the thermometer. One of the most basic installations and first image that comes to mind when you think of a thermometer is the mercury thermometer, the type that you find in the laboratory. It consists of a capillary tube joined with a bulb containing mercury at one end of the thermometer. The capillary tube along with the bulb are encased in glass that is lined with a reading scale measuring temperature in unit degrees Celsius. The digital thermometer consists of a temperature sensor, signal conditioning circuitry, a power supply, microcontroller, and an analog to digital converter. Looking on the surface, there is a hold button, reading display, power button, unit change button, and a probe with a probe tip that may come with a probe cap to close it. Within an infrared thermometer is the optical system, infrared detector, and a signal processing unit. From an external point of view, there is a scan button, LCD display, battery cover, and functional buttons. The thermocouple thermometer typically includes two dissimilar metal wires, a cold junction, two copper lead wires, and a voltmeter. The constant pressure gas thermometer consists of a sealed glass bulb containing hydrogen or helium joined to a pressure gauge via a capillary tube. The pressure gauge is also joined to a mercury reservoir lined with a scale via a flexible tube. The components of a mechanical bimetal thermometer are a pointer, sliding bearing, rotatable rod, cylindrical pin, and bimetal connected pin, helical bimetal strip, stem, and bimetal connected to rod. Plastic strip thermometers appear as thermochromic liquid crystals encased in plastic, which are attached to a black backing lined with adhesive and carrier components on one side. The next instrument I now have to talk about is the hygrometer. One type of hygrometer is often referred to as the higher tension hygrometer. It is made up of a humidity scale, pointer, pivot, humidity sensor, which is where the hair could be found in the instrument, tension spring, and a lever. Humidity indicator cards are moisture-sensitive cards which change color when exposed to specific humidity levels. They also come with desiccants inside moisture barrier bags. A metal paper called hygrometer consists of a thin metal strip bonded to a hygroscopic paper or polymer strip. Alongside that, there is a humidity scale, pivot, mounting wood, and laminate. The primary components of a psychrometer are two thermometers, wet bulb with wick and dry bulb. It has reading scales, a swivel, and a handle. One apparent similarity between thermometers and hygrometers is that they both measure aspects of the environment that they may concern the quality of the air. The general function of any thermometer is that they are made to indicate the temperature of any physical matter, including the air. On the other hand, hygrometers are seemingly exclusively created to measure the humidity or relative humidity of the air. The specific function of a mercury thermometer is that they can measure solid temperature, liquid temperature, and gas temperature. In terms of application, they are involved in chemical reactions in laboratories, distillation and fractionation, thermal analysis, environmental studies, freezing point determination, industrial settings, household uses, and medical applications. Similar to mercury thermometers, digital thermometers also measure and monitor temperatures as a specific function. They monitor body temperature, perform temperature screenings, are found in clinical settings, help monitor food safety and quality, and are found in houses, industries, and laboratories. An infrared thermometer infers temperature from a portion of thermal radiation, sometimes called black-body radiation, emitted by the object being measured. And they are used in industries for electrical system and building inspection, houses, agriculture, sciences, firefighting, security, and food safety. Thermocouple thermometers function in many applications where mercury and infrared thermometers are also found. They ensure good quality in food and beverages, record temperatures in houses and bodies, and are further found in various industries. Constant pressure gas thermometers work in the energy sector, food industries, pharmacies, and biotechnology, wastewater treatment, mechanical engineering, research and development, and across all industries in general. Mechanical bimetal thermometers are commonly found in machine buildings, heating systems, air conditioners, and refrigerators. Plastic strip thermometers are often applied to forehead temperature measurement, educational demonstrations, cold chain logistics, propane gas level tank indicators, aquarium temperature measurement, and home brewing. The specific function of a hair tension hygrometer is that it can monitor relative humidity in all sorts of environments. This can be done in houses, offices, greenhouses, and agriculture, storage and preservation, incubators and saunas, and research and education. Humidity indicator cards are involved in electronics manufacturing, pharmaceuticals and medical supplies, food and beverages, aerospace and defense, transportation and shipping, and museums and archives. Metal paper core hygrometers are typically found in greenhouses, warehouses, homes, humidors, saunas, steam rooms, and some egg incubators. Psychrometers measure relative humidity as a key factor in various fields, including meteorology, agriculture, and healthcare. While different versions of either thermometer or hygrometer all measure temperature or humidity, and often overlap in application and occupation, their steps on how to use them are quite different and more difficult to pin down. Before using a mercury thermometer, it has to be cleaned to prevent infection towards the sample or physical matter being inspected. The thermometer has to be taken firmly to calibrate the mercury in the capillary tube to below a temperature reading of at least 35 degrees Celsius. You also have to make sure it isn't broken as leaking mercury is toxic to you. After all this, choose a surface or center of the substance where you want to place the bulb of the thermometer. Keep the bulb in that position until you see the mercury in the capillary tube stop rising. Read the temperature reading on the scale relative to the location of the meniscus of the mercury. Once you are done, clean and disinfect the thermometer as well as store it away safely. The probe with the digital thermometer has to be cleaned before initiation. Next, press the activation button of the instrument to turn it on. Just like with a mercury thermometer, place the probe in or on the desired location of the subject you are measuring. Read the complete measurement on the display screen after hearing a beep sound and remove the probe from the subject. As you finish, clean and keep away the utensil. Similarly to the digital thermometer, press the power button of the infrared thermometer. Select the appropriate mode and temperature scale of your application. Allow the device to warm up for at least 15 minutes. Set the thermometer in a way that is perpendicular to the surface of the object you are recording the temperature from and estimate the correct distance to take a measurement. Press the trigger, release, and look at the temperature reading displayed. It should be important to consider that the tool has to be clean and free from scratches. Another consideration should be to avoid direct sunlight, excessive perspiration, steam, or dust as they harm the accuracy of the readings you would take. For this, select the right thermocouple type for the specific temperature range you will be working with. Connect the thermocouple probe into the appropriate connector on your measurement device, turn it on and select the desired temperature unit. Place the probe in or on the location of the object you are measuring as you would with a digital thermometer. Finally, read the recorded temperature display on the screen. The constant pressure gas thermometer is calibrated to the freezing and boiling point temperatures of water. Put the gas bulb in direct contact with the surface you chose to measure the temperature. Observe the movement in the mercury column and the change in gas volume. This calibrates to a temperature reading. Before the mechanical bimetal thermometer can begin to be used, it has to be calibrated using the freezing point method or ice water bath. 2/3 of the stem's length has to be immersed in the medium to be measured. Avoid areas with strong airflows and temperature fluctuations. For industrial applications, mount the thermometer away from the vibrations. Wait for the dial to stop moving before reading the temperature. Clean and sanitize the thermometer. When using the plastic strip thermometer, make sure the surface you are measuring is clean and dry. Peel off the backing of the thermometer strip and place it firmly on the surface. Holding the strip in place for approximately 15 seconds, after the specified time, remove the strip and observe the color changes. The color changes correspond to a temperature change indicated on the strip. In a hair tension hygrometer, hair shortens when humidity decreases and it lengthens as humidity increases. The movement of the hair is magnified by the lever which moves the pointer. You have to look at where the pointer is pointing at on the scale to find out the relative humidity. Before using the humidity indicator card or cards, make sure the interior and exterior surfaces of the packaging is clean and free from contaminants. Place the card in the package and seal it. Regularly observe the color changes from blue to pink on the card and find out the humidity percentage by looking at the indicated temperature range next to the spots that changed in the color. With this instrument, place the metal paper called hygrometer at the location where you want to measure the humidity. Allow the hygrometer to equilibrate with the surrounding air temperature and humidity. After a few minutes, the coil has been bent in the response to the absorption of moisture by the paper strip, which leads to the movement of the pointer on the scale. Read the result on the scale. To start using the psychrometer, remove the cap from the wet bulb and saturate it with distilled water. Hold the handle and whirl the psychrometer in the air for 1 to 2 minutes or until the wet bulb temperature stabilizes. After the whirl, quickly read the wet bulb and dry bulb thermometer readings. Subtract the wet bulb temperature from the dry bulb temperature. Use the pressure and the dry bulb temperature to find the relative humidity on the psychrometric table or use a formula. While both the thermometer and hygrometer fulfill their intended roles in one way or the other as environmental instrument, each distinct design comes with a whole host of pros and cons when applied. The mercury thermometer comes with many advantages. It can measure a wide temperature range without changing into different states of matter. The thermometer can detect the slightest fluctuations in temperature in its surroundings, and the readings will change to detect the temperature alteration. Mercury also expands uniformly with increasing temperature, allowing for a linear temperature scale and precise measurements. It also has a characteristically low adhesive property, making measurements more precise as it would not stick to the side of the tip when rising. Mercury is chemically stable too, meaning that it won't react with any of the material in the thermometer. However, mercury thermometers even have their disadvantages. For one, the glass that significantly makes up the thermometer is fragile and can easily break. Since mercury is toxic, it can harm you when the instrument leaks and can contaminate environments when released into the ecosystems. It also cannot measure temperatures above its boiling point or below its freezing point. Plus, they are not as precise or accurate compared to their digital counterparts. In contrast, digital thermometers are easier to read and make more precise measurements than mercury thermometers. They are easier to read and they are safer too and conveniently portable. Unfortunately, they are also dependent on batteries, so they need to be replaced. They can spoil easily too when exposed to specific liquids or gases, as opposed to non-digital versions. Furthermore, they are generally more expensive than them too. On top of being user-friendly and making quick and accurate measurements, infrared thermometers are well known for being able to scan temperatures from surfaces without being in direct contact with them. This means they require less cleaning and maintenance. Also, they are even able to measure temperatures of fast-moving objects. Besides that, they can be affected by environmental factors such as unwanted light, cold temperatures, and minor obstructions. They can only measure the surface temperatures instead of internal ones, and even then, the surface will have to be opaque for measurement to proceed properly. In fact, they may even be temporarily affected by electromagnetic fields. Thermocouple thermometers are able to measure cryogenically low temperatures and temperatures as high as 2000 degrees Celsius. They are cheap, durable, very responsive to temperature changes, self-powered, versatile, and simple in design. Of course, they also have their drawbacks. They generate small output signals and are susceptible to electrical noise and possibly lose recalibration capability after experiencing excessively high temperatures. Constant pressure gas thermometers can be highly accurate and have a wide scale range, but need a long time to set up or measure and are unable to quickly react to rapidly changing temperatures. Plastic strip thermometers are convenient, safe, affordable, portable, and have reduced cross-contamination, but may not be as accurate as more advanced thermometers, sensitive to ambient temperatures and have limited applications. Hair tension hygrometers are simple, affordable, versatile, and require low maintenance. However, they can give inaccurate readings, struggle to measure rapid humidity fluctuations, the hair can be easily damaged, and only measure absolute humidity. Humidity indicator cards are simple, cheap, accurate, and are versatile. They enhance good production and allows for timely intervention. Unfortunately, they could be toxic, barely accurate, and are susceptible to damage. Plus, they need proper storage. Metal paper call hygrometers are inexpensive, easy to read, simple in design, versatile in application, and can detect changes in humidity effectively. On the downside, they are quite inaccurate, and this inaccuracy tends to get worse over time. Furthermore, they are also hard to calibrate. Psychrometers are simple and low cost, provide accurate measurements, versatile and portable, easy to use, have a wide range temperature, and are not affected by high humidity or condensation. At the same time, they need regular maintenance, manual operation, rely on charts and calculations, and are not adapted to automated monitoring. To summarize, the entire video presentation centers around thermometers and hygrometers and their multiple variations that fits all sorts of niches. There were a total of 6 types of thermometers in this video, including mercury thermometers, digital thermometers, and infrared thermometers, thermocouple thermometers, constant pressure gas thermometers, and plastic strip thermometers. Other than that, there were a total of 4 types of hygrometers in this video, including hair tension hygrometers, humidity indicator cards, metal paper hygrometers, and psychrometers. All the instruments mentioned were small in size and could easily be carried. The inner machinery was either simple or complex. Thermometers measure temperatures and hygrometers measure humidity. Versions of either instrument followed their main function and even overlap greatly in terms of work utilization and application. Some procedures required to operate the instruments were simple, others required more steps to complete. Lastly, from my evaluation and research, there were roughly an equal amount of advantages to disadvantages to the two types of tools when comparing their counterparts. That is all for the video. I hope you enjoyed and learned something new from it. This was one of my most daunting assignments that I ever had to complete. Thank you.